Hello, I'm Lorcan.
I'm Ross.
And today we're in Millport on the Isle of Great Cumbrae, which is one of the Cumbrae Islands in the Firth of Clyde in the county of Bute in the council area of North Ayrshire in the west of Scotland, which is in Scotland.
Like here, much of Scotland's coast is dominated by seaweed and mackerel. These species play an important role in the preservation and upkeep of our seas. However, they are being removed at an alarming rate for a variety of reasons, such as animal feed, cosmetics, and fertilizers.
A lot of these products are marketed as being organic and sustainable, but we're here today to assess whether this is true or whether seaweed can be cut sustainably or not cut at all.
Holding my hands, a species of brown seaweed or mackerel known as kelp. Underneath the water, kelp forms vast forests of seaweed life.
At low tide, these leaf-like fronds form a protective cover for intertidal species, but at high tide, they float and provide a protective habitat for a wide variety of species.
These species include small sessile invertebrates, sea urchins, small fish, and crustaceans, many of which are commercially important. Larger predatory fish, birds, and cetaceans take advantage of the abundant food source, together making up a diverse ecosystem.
Like the plants we have here on land, kelp is capable of photosynthesis, harnessing the energy of the sun. This provides energy to support these diverse coastal ecosystems.
It possesses air-filled bladders that allow it to float in the floating zone and maximize light exposure. This way, seaweeds can absorb massive amounts of carbon.
It's estimated that they remove around 634 million tons of carbon from the air each year.
And unlike terrestrial forests, all the carbon sequestered by kelp forests is exported to the deep sea for more secure, permanent storage.
Kelp grows very slowly, with some species living up to 400 years old. This, combined with low phenotypic differentiation within the population, hinders recovery from cutting.
Species with these characteristics cannot be held to the standard levels of maximum sustainable yield without huge negative impacts on the rest of the ecosystem, including reducing abundance or biomass of potentially commercially important fish.
There are indirect and direct impacts of cutting rockweed forests. Indirect impacts are due to the change of habitat because rockweeds that are less than 130 centimetres are more than halved in height. This affects fish as their biomass is decreased due to the lack of food and habitat destruction.
Also, common eider ducklings use the rockweed as a nursery and feeding ground. Cutting destroys the nursery, leaving the ducklings exposed to predators. A suggestion from researchers is to cut the rockweed in early to mid-July.
Rockweed cutting also decreases the species richness and intertidal abundance of species such as green crabs, periwinkles, limpets and colonial hydroids.
Direct impacts on the rockweed include the removal of species, the alteration of rockweed bed structure, and plant morphology. When rockweed is cut, branches are formed and produce rockweed bushes. This affects the growth rate, and it has been found that in some cases the rockweed can take longer than 2 years to grow back. A maximum 17% biomass harvest level has been put in place based on maximum sustainable yield, but this is still argued to be too high for rockweed to recover.
To evaluate sustainability, data has been analysed on growth rates and the influence of various confounding factors, including the age of the plant and wave exposure.
The holdfast effect describes the impacts of cutting methods on rockweed mortality rates. If mechanical methods are used, then the likelihood of mortality is up to 36%. However, less destructive methods such as hand cutting results in a 17% mortality rate.
All this seaweed is being removed without any data on sustainability. Current regulations for sustainable harvest have been deemed far too high and are not based on any long-term research. Further studies must be done into the impacts of removing seaweed on the ecosystem.
Until this research is undertaken and data-driven regulations are developed, it can be argued that all commercial-scale rockweed cutting should be halted completely. As prime producers, rockweeds and kelp form the basis of coastal ecosystems, and it's been shown that removing 17% of biomass removes 34% of net primary productivity. Not only are these species under threat from mass removal, they also face threats from warming ocean temperatures and eutrophication.
I don't need the ones I want.